Let's graph together this exponential function. The first thing that we know about exponential functions is that the domain of them is always all real numbers, from negative infinity to positive infinity. If I want to find the range of an exponential function, then I need to wait until I see my graph. I cannot determine the range until I see the graph. One thing that I know about exponential functions is that they don't have any vertical asymptotes, and this is always true. The horizontal asymptote of an exponential function, it is determined by the constant of the function. So, the horizontal asymptote for this case will be y is equal to -4. In order to graph an exponential function and not to get confused about the graph, I have to do it in stages. The first thing that I consider is the horizontal asymptote. The second step, I'm going to rotate around the y-axis if the sign of the exponent is negative. So the sign of the exponent right here is what determines if I rotate around the y-axis. If it is negative, I do. If it's positive, then I don't rotate. The third step is going to be to look at the sign of the base. So in this case, the sign of the base is plus because I have a +3 at this point. If the sign of the base is negative, then this would mean that I rotate around the horizontal asymptote. At the fourth step, what I do is I focus at my number, the constant that I add to the exponent. So in this case, the number 1. So if I add the constant, let's say k, then this means that I will shift my graph to the left. If I subtract the constant, then this means that I will shift my graph to the right. So again, I have a horizontal asymptote, and this is going to be, in this case, -4. The sign of the exponent. If the sign of the exponent is negative, then I rotate around the y-axis. The sign of the base. If the sign of the base is negative, then I rotate around the horizontal asymptote. And at the end, I shift to the right if I have a negative number constant at the exponent, and I shift to the left if I have a positive one. So, let's start. First step, I remember that my exponential functions look like this. So I graph. I determine the HA, that is at -4, and my function will look like that. The second step, I focus on the sign of the exponent. In my case, the sign of the exponent is negative because I have 3 to the negative x plus 1. This is negative. So this means that whatever I had from the first step, now I need to rotate it around the y-axis. So this is going to move to that, and it will converge to positive infinity. Third step, I look now at the sign of the base, and here I have +3 to the negative x plus 1. So I focus on that. Since it's positive, I do not rotate. If it was negative, I would rotate around the HA, the horizontal asymptote. But in this case, I don't. I leave the graph as is. At the fourth step, I need to shift. I shift basically based on the number that I add at the exponent, the constant. And here I have plus 1. So this means that I'm going to shift to the left 1 unit. So what does this mean? This means that basically my graph will remain the same, but it will converge to the infinity, to the horizontal line sooner. And finally, the fifth step, I need to identify 2 points. The easiest to find is the Y-intercept, and there will always be a Y-intercept. So I plug in 0 for x and I calculate. And I have 3 to the 0 plus 1 minus 4. And this gives me 3 minus 4. That is equal to negative 1. So my Y-intercept is going to be the 0, negative 1. Let's find one more point. The easiest way to find where it will be the best point to find is where do you have your angle. The angle is on this way, so let's choose the negative 1. And I will find the value for negative 1 in order to determine my point. So I have 3 to the negative of negative 1 plus 1 minus 4. And this is equal to 3 to the second minus 4. And this is equal to 9 minus 4. And this means that my number is 5. So I have 0, 5. I'm sorry, 1, negative 1, 5. That's my second point. In this case, I'm ready to graph my exponential function. I know what is my horizontal line, my horizontal asymptote. I find the Y-intercept, that is right here. And I also need to find the second point, that is 1, 2, 3, 4, 5. So it's going to be right here. So my graph will be the following. And it will converge to the y equals to negative 4. Okay. Now, the next thing that I want to do is to make sure that I find the range. As you can see, right here, all the points from negative 4 on the y-axis and up to the positive infinity are possible y-coordinates for the points of the curve. So my range is going to be from negative 4, parenthesis here because the negative 4 is the horizontal asymptote, to positive infinity. And I'm done with this graph.